This lesson is going to focus on simplifying algebraic expressions. Now, we've done a lot of simplifying of expressions with just numbers and exponents, but not a lot of variables in there. So when we get an algebraic expression, that means we have a variable, x, y, r, m, n, any of those. So if we have 2 plus 2, that's 4, and you can add those up because these are like terms. They're both a constant. Okay? Well, if I have a rectangle plus a rectangle, that's going to equal 2 rectangles because I'm adding the same thing. But if I have a rectangle plus a circle, well, guess what? Those don't combine. They're different. That's going to just be a rectangle plus a circle forever. You can't smush those together into one thing. So because in the second example, these were like terms, it was both a red rectangle of the same size, I could combine that and say, oh, I have 2 of those. In the third example, those were different, so they don't combine. So if you look on the right side of that equation, those are the same as what you started with because you can't combine them. Okay, that's kind of the idea behind like terms. So right now I'm looking at number 1 on 1/6 simplifying algebraic expressions, and I'm looking at 9r minus 10r. Now what makes these like terms is they both are an r to the first power. Remember, if there's no exponent, there's an understood one there. So I have 9 r's, and I'm going to subtract 10 r's. Well, this goes back to our positive and negative integers. 9 minus 10 is a negative 1, and then your r to the first power kind of travels along with it. So negative 1r is the same as negative r. A coefficient of a 1 we usually don't write because it's meaningless. Okay? So you can see on number 1, the correct answer would be B. Now let's do one of these that's a little more complex. Let's look at number 11. Number 11 brings into light a new property, which is called the distributive property. You're going to use the distributive property all through math. In all of your upper level math classes, you will use the distributive property over and over and over. So you see this set of parentheses, and there is a coefficient or a constant right outside the parenthesis, and there's no symbol between. When there's no symbol, we always have an imaginary multiplication. Just like if there's no exponent, there's an imaginary 1. Whenever you have this distributive property, that's the setup you're going to have. You have to take this negative 6 out front, and you're going to multiply it by the p. Negative 6 times p turns into negative 6p. You're also going to multiply it times negative 4. Well, remember the pizza guy. We have a negative 6 times a negative 4, so we've used the negative and the negative. The product would then be positive, so it's positive 24. This negative 7 out here on the end is just going to travel right along. Now I have 2 like terms, the 24 and the negative 7, because remember, minus 7 is the exact same thing as plus negative. So negative 6p plus 17 is the simplified form of number 11. So that's B. So in this lesson, we're really going to use a lot of this distributive property. We're going to go all the way to number 30, most complex one on the page. So we have negative 8 times the quantity negative 5 minus 5x plus 6 times the quantity x plus 5. Both of these are the distributive property. So I always draw these humps because it tells me which two things to multiply. Whatever it connects, that's what I'm multiplying. So negative 8 times negative 5 is positive 40. I also have to distribute that negative 8 to the negative 5x. Negative 8 times negative 5x is positive 40x. Now let's go to the second piece, which is a second distributive. 6 times x is positive 6x, and 6 times 5 is positive 30. Now I have some like terms. I have a 40 and a 30, and I also have a 40x and a 6x. So 40 and 30 will combine to give me 70, and 40x and 6x will combine to give me 46x. So if you look at the answers on number 40, the correct answer would be D, 70 plus 4x. So that is the distributive property, and that pretty much will take care of simplifying algebraic expressions. You're looking for like terms. One example that people will do is they'll have something like that, and they will say, oh, that's n cubed. No, 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 that does not equal n cubed. Remember, n cubed is n times n times n. Those are not nearly the same things. N squared plus n is two unlike terms being combined, and it simply equals n squared plus n. That means it cannot be simplified any farther. That is in simplest form. So be careful when you have bases with different exponents and you're adding or subtracting. They do not combine any farther if they are not the same base with the same exponent. Okay, good luck.